to another awesome day of geometry with Mr. Virtual Coach. Today we're going to talk about isosceles triangles and equilateral triangles and how their congruent sides and subsequent congruent angles make our lives a little easier when we're trying to solve for these two specific triangles. So first off, we got to talk about some of the parts of our isosceles triangle. We've got two congruent sides, which we call our legs. Where our two legs come together, that's our vertex angle. So if you look at the picture on the left, so the congruent sides are my legs. Where those two congruent sides come together is my vertex angle. The side that is opposite, so across from the side that is opposite my vertical angle is called my base. And the angles along my base, in this picture is 2 and 3, are called base angles. I know, they try to make it as complicated as possible, right? So, we've got a couple theorems. One is the just straight up conditional statement, and the other is the converse. So if two sides of a triangle are congruent, in this case it's an isosceles triangle, so those sides are congruent. If A is congruent to B, then we can say the sides that are the angles that are opposite those congruent sides, those angles are going to be congruent as well. So if my sides are congruent, the angles that are opposite them are also congruent. And then the converse of that, remember, just flips the hypotenuse and conclusion. The converse of that is, well, if these angles are congruent, then by definition, those sides must be congruent. So for an isosceles triangle, we'll always have two congruent sides, which we call legs, and two congruent base angles. And then our vertex angle is just on its own. So let's do a little geometry. Let's do a little math. Okay, so we look at number 1. It wants us to find the measure of J, find the measure of K. So we have an isosceles triangle. Woo! We just did a little loop-de-loop right there. Hang on, another loop-de-loop coming. So we've got our two congruent sides. They show us congruence with these tick marks, which means if these two sides are congruent, the angles that are opposite those sides are also congruent. So they told us the measure of L is 68. Well, this angle that is opposite that other congruent side is angle J, and if L is 68 as a base angle, the angle that it's also, the other base angle must be 68. Now that we have two of our three angles, it's going to do it, isn't it? Now that we have two of our three angles, okay, my handwriting is just going to be sloppy because I don't want y'all to have to see that box. But now that we have two of our three angles, we can use this triangle sum theorem that we talked about last week to find the missing third angle. So remember, the triangle sum theorem tells me if that all three of these angles, so L, J, and K, are all going to add up to be 68, or 180, I'm sorry, I saw 68 and I went with it. So the measure of K plus 68 equals 180. Combine like terms on the left side. Measure of K plus 136 equals 180. We're going to subtract 136 from both sides. So the measure of angle K is what? 44? So 44 degrees. All right, let's look at number 2. This time they gave me the vertex angle. Right? They told me that I've got an isosceles triangle with my 2 congruent sides, which means that these 2 angles that are opposite our congruent sides are themselves congruent. I know they've got measure of C, measure of E up there, but just for our sanity, let's say this is X, and if that angle E is X, then angle C must also be X because it is congruent. So we go triangle sum theorem. 106 plus X plus X equals 180. Combine like terms on the left side. So 106 plus 2X equals 180. Remember, guys, we're trying to isolate X. So we want to move everything away from it that we can to get it by itself. So we're going to subtract 106 from both sides. So 2X equals 74. Now that we've got it down there, we're just going to divide both sides by 2. So X equals 60, whoops, 60, you silly goose, 37. So that means each of those angles is going to be 37 because their sum together needs to be 74. All right, number 3. Now they told me angles and they want me to figure out sides. So remember, if my 2 base angles are congruent, the side opposite those are also congruent. So if one of my sides is 12, that means my other leg must also be 12. We do not have the ability to find this base yet. Keyword yet. That's coming. Okay, now that we can do that, let's go ahead and try to find our missing vertex angle up here. Let's go a different color. Okay, so we want to find angle Y. Remember, triangle sum theorem. The measure of angle Y plus 77 plus 77 equals 180. So the measure of Y plus 154. Subtract 154 from both sides. That means the measure of Y is 26. Now, they can throw some straight up algebra at us, and that's okay. We like that. We can handle that. So they give us an isosceles triangle. Hey, I know it's isosceles because they got those 2 tick marks right there. Those 2 tick marks are telling me that those 2 sides are congruent. So because those 2 sides are congruent, the opposite base angles are congruent. Now, I know a lot of you guys are like, well, wait, coach, there is no third angle. What am I supposed to do? Could I just drop an X in here? Do not do that. Remember, if my sides are congruent, my angles must be congruent. So we can just set these rascals equal to each other. So 5x plus 9 must be equal to the other base angle, 8x minus 30. Now, we just got our basic linear expression. So we want to roll through. So we combine, I'm going to move x to the right just because I like dealing with a positive x. You know, I'm a positive guy. So we got 9 on the right equals 3x minus 30. Don't ask me why I put that plus in there. I just did. It's okay. Let's take it away. Don't want to rattle your brains. Now we're going to add 30 to both sides. So we get 39 equals 3x. Divide both sides by 3. X equals 13. Now that we know x, we could try to find that vertex angle, but our description didn't want us to do that, so we're good. Let's take a peek at number 6, because now it's talking about the sides. So these hoops, there it is. These hoops tell me that those two angles are congruent. And our converse says if those base angles are congruent, then the opposite sides must be congruent. So again, we're just going to take the values they gave us and set them equal to one another. So we're going to take 15x plus 7 and make it equal to 23x minus 17. Solve for x. That's all our goal is now, guys. We got to get x all by itself. So we're going to add 15 or subtract 15 from both sides. 7 equals 8x minus 17. Now we can add 17 to both sides. So 24 equals 8x. Divide both sides by 8. X equals 3. All right. 5 and 7 were the same as what we just done, so we're not going to cover in the video, but I will have them on the completed notes for you. Look at the next page. Word problems. Word, homie. All right. RST. If RT is congruent to ST, they gave us the measure of our three angles. Find X and the measure of all three angles. So again, our biggest advantage here is we need to draw this out, because even as smart as I know each and every one of you are, sometimes being able to see doesn't really work. And maybe one of these times I'll draw an isosceles triangle. That's pretty close. So we're going to label our corners, our vertices, RST. We know RT is congruent to ST. Of course, they got me. R is 9x plus 2. S is 13x minus 18. And T is 17x plus 1. Okay. So we can do the triangle sum theorem if we want and just add them all together and set them equal to 180. That is a tactic you can use, but because we're talking about isosceles triangles, I'm going to focus on those rules. So here's my congruent sides. Oh, that's the other day's notes. I've got this, so R is opposite that one, and S is opposite that, which makes T my vertex angle. Remember, guys, not all pictures are drawn to scale. We can't assume anything on looks. It is what it is. All right, so we're using our isosceles theorem. If those sides are congruent, that means those angles are congruent. So I can just take those two base angles and set them equal to one another. So 9x plus 2 equals 13x minus 18. Oops. Disappear an 8. So we're going to subtract 9x from both sides. 2 equals 4x minus 18. Add 18 to both sides. 20 equals 4x. Divide both sides by 4. So x equals 5. Now that we know that, we're just going to substitute that value into each expression. So 9 times 5 plus 2. 45 plus 2 is 47. 13 times 5 minus 18. 13 times 5 is 65. 65 minus 18 is 47. And our last one, 17x plus 1. Not sure what on earth happened out there, but 17x plus 1. So 17 times 5, so 85 plus 1 is 86. So we know the measures are x is 5, r is 47, s is 47, and t was 86. And then that total should add up to 180. So 47 and 47 is 94. 94 plus 86 is indeed 180 degrees. All right, triangle DEF. D is congruent to E. So let me see if I can get this daggone picture right, not trying to mess with y'all's brains. So we get our isosceles triangle. Did not work. Let's try it again. There we go. So angle D is congruent to angle E, so this guy's going to be F. So D is congruent to E. DE is x plus 4, that's our base. EF is 4x minus 8. And DF is 7x minus 35. So remember, guys, if these angles are congruent, that means their opposite sides are also congruent. So we can set these two sides up equal to one another and solve for x. So 7x minus 35 equals 4x minus 8. Subtract 4x from both sides. 3x minus 35 equals negative 8. Add 35 to both sides. 3x equals, oh boy, 27. Divide both sides by 3. X equals 9. Now that we know x equals 9, we plug it in, solve to get our values. So 4 times 9 minus 8. 36 minus 8 is 28. Now remember, guys, these are sides, so they don't have to add up to anything specific. 7 times 9 minus 35. 7 times 9 is 63. 63 minus 5 touchdowns is going to be 28. I'll put a degree mark. And then lastly, 9 plus 4, which is 13. Okay, so guys, those are isosceles triangles. And remember, those rules don't have, so when there's sides like that, it doesn't have to add up to anything particular. So DE was 13, and the other two were 28. All right, so that covers our isosceles triangles, but now let's take a peek at equilateral. So remember, it's equilateral if and only if it is equiangular. So if my angles are all congruent, my sides must all be equal. And if my angles are my sides are all equal, then my angles, a little loop-de-loop just to make sure you're staying with me. And if my sides are all equal, then my angles are all equal. And these angles right here, guys, these will always be 60 degrees. In an equilateral triangle, the angles will always be 60 degrees. All right, so they said find the missing measure. So I can go triangle sum theorem here. So measure of C is my unknown. Plus 60 equals 180. Hopefully we start to realize that if two angles are already 60, the third one has to be 60. But let's do the math for fun, because math is fun. Combine like terms on the left side. Measure of C plus 120 equals 180. Subtract 120. So the measure of angle C is 60. So since all three of my angles are 60, this rascal has to be is equiangular, which means it has to be equilateral. So C was 60, and that if it's equilateral, each side has to be 9 feet. All right. JKL, they gave me 3 tick marks. Guys, those 3 tick marks tell me I've got 3 congruent sides. And if I've got 3 congruent sides, I've got 3 congruent opposite angles. 60, 60, 60. No math required because we got those big brain smarts. Last one, it's a doozy. Okay, so they've got a lot going on. So we've done this part already where we can just pick any side we want and set it equal to one another. So let's get that out of the way. We know it's equilateral. They told us in the problem it's an equilateral. We're going to just roll with it. So I'm going to pick 11y minus 23 equals 9y plus 1. Solve for y. 9y on both sides. 2y minus 23 equals 1. Add 23 to both sides. 2y equals 24. Divide both sides by 2. Y is 12. Sweet, that's y. Okay, x is a little trickier. We've got to think about what's happening. So if we know that it's an equilateral triangle, which we do because, hey, newsflash, they told us, we know that each of these angles must be congruent. And if each of those angles must be congruent, they each have to equal 60. So this measurement right here, I could multiply it times 3 and then set it equal to 180 and all that fun stuff. But why would I give myself that much extra work to do? Because we're intelligent enough to figure out, well, if it's equilateral, then that angle has to be 60. So why am I going to waste my time with the triangle sum theorem when I can just say, well, 7x minus 3 in this equilateral triangle, this guy has to be 60. So I'm going to set that rascal equal to 60 degrees. And then I made my life just a little bit easier. So we're going to add 3 to both sides. 7x equals 63. Divide both sides by 7. X is 9. And if you did triangle sum theorem because that's what you're comfortable with, great. That's awesome. It'll work as well. But I also want to be able to help you guys and give you guys the key to be able to accomplish what you need to accomplish without sitting there and bogging yourself down with unneeded algebra. Remember, the angles of our equilateral triangle will always be 60. So if I pop one of these on your quiz or your test, be like, no, 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 Mr. Coach, I'm not going to waste my time doing the triangle sum theorem. I know this angle has to be 60, so I'm going to set it up that way. Guys, thank y'all so much for watching. Get your homework done, and we'll see y'all tomorrow.